Welcome to our video on the role of oceans in regulating Earth's climate. Oceans cover over 70% of our planet and play a critical role in maintaining the delicate balance of our climate system. From absorbing heat and carbon dioxide to influencing weather patterns and marine ecosystems, the oceans are a powerful force in climate regulation. Join us as we explore key topics, including the ocean's role as a heat reservoir, its impact on the water cycle, and the challenges it faces from climate change. Dive in with us to uncover the vital functions oceans serve in supporting life on Earth. 1. Heat absorption. The ocean's protective blanket. Oceans act like Earth's protective blanket, absorbing about 90% of the excess heat generated by human activities. This remarkable ability helps buffer the Earth's climate from rapid temperature changes that could otherwise be catastrophic. Imagine the oceans as a giant sponge, soaking up heat that would make our planet much hotter. This heat absorption plays a crucial role in maintaining a stable environment where life can thrive. Without the oceans, our world would see dramatic temperature fluctuations that could disrupt ecosystems and make certain areas uninhabitable. By absorbing so much heat, oceans help slow the pace of climate change, giving us more time to adapt and find solutions. 2. Oceans. The world's largest carbon sink. The oceans are often referred to as the planet's largest carbon sink, absorbing approximately 25–30% of human-generated carbon dioxide, CO2, emissions annually. This process is vital in mitigating climate change, as it reduces the amount of CO2 in the atmosphere, which is a major driver of global warming. Think of the oceans like a giant vacuum cleaner, inhaling carbon dioxide and preventing it from causing harm. However, the more CO2 the oceans absorb, the more acidic they become, which can have negative effects on marine life and the ocean's ability to continue absorbing carbon. This delicate balance highlights the importance of protecting our oceans and reducing CO2 emissions. 3. Thermohaline circulation. The ocean's conveyor belt. The ocean's currents, particularly the global thermohaline circulation, act as a conveyor belt, distributing heat around the globe. This circulation is driven by differences in water temperature and salinity, moving warm water from the equator towards the poles and bringing cold water back down. By doing so, it influences weather patterns and regional climates, playing a key role in regulating the Earth's temperature. Imagine a giant underwater highway system that moves heat and nutrients to different parts of the world. Disruptions in this circulation could lead to extreme weather conditions, such as more severe winters in Europe or prolonged droughts in other regions. 4. Regulation of atmospheric temperature. A slow release. Oceans have the unique ability to moderate atmospheric temperatures by releasing stored heat slowly over time. This gradual release helps stabilize the global climate, preventing extreme temperature swings that could harm ecosystems and human populations. Picture the ocean as a giant thermostat, constantly adjusting to maintain a comfortable environment. By absorbing heat during warmer periods and releasing it during cooler times, the oceans ensure that our climate remains relatively stable. This regulation is essential for maintaining the delicate balance needed to support life on Earth. 5. The ocean's role in the water cycle. Oceans play a central role in the water cycle, providing moisture for precipitation and influencing cloud formation. This, in turn, affects weather patterns and temperatures across the globe. Imagine the oceans as a giant water fountain, constantly evaporating water that eventually falls back to Earth as rain or snow. This process is crucial for maintaining the planet's freshwater supply, which is essential for all living organisms. Without the oceans, the water cycle would be disrupted, leading to droughts in some areas and flooding in others. Understanding the ocean's role in the water cycle is key to predicting and adapting to changes in our climate. 6. The albedo effect. Reflecting sunlight. The ocean's surface reflects sunlight, a phenomenon known as the albedo effect. This reflection plays a role in regulating the Earth's temperature by determining how much solar energy is absorbed or reflected back into space. Changes in ice cover and ocean coloration can significantly influence this process. For instance, when ice melts, the darker ocean water absorbs more heat, contributing to global warming. Conversely, when ice is present, it reflects more sunlight, helping to cool the planet. This delicate balance underscores the importance of monitoring changes in ocean and ice conditions as part of our efforts to understand and address climate change. 7. Oceans and hurricanes. Fueling the storm. Warm ocean waters are the fuel for hurricanes and tropical storms. As the Earth's climate continues to change and oceans warm, the intensity and frequency of these storms are increasing. Picture the oceans as a massive energy source, providing the heat needed to power these powerful weather events. With warmer oceans, hurricanes can grow stronger and more destructive, posing a significant threat to coastal communities. Understanding the relationship between ocean temperatures and storm formation is crucial for improving weather predictions and preparing for the impacts of these natural disasters. 8. Acidification. The ocean's chemical challenge. As oceans absorb more CO2, they become more acidic, presenting a challenge for marine life. This increased acidity can have harmful effects on organisms like corals and shellfish, which rely on calcium carbonate to build their shells and skeletons. Imagine the oceans as a giant chemistry lab, where changes in pH levels can have far-reaching consequences. Acidification not only impacts marine ecosystems but also affects the ocean's ability to regulate CO2 effectively. Addressing this issue requires concerted efforts to reduce carbon emissions and protect the delicate balance of marine environments. 9. Storage of greenhouse gases. The ocean's hidden reservoir. Our oceans store not only CO2 but also methane and other greenhouse gases in sediments and deep waters. This storage plays a crucial role in the long-term regulation of Earth's atmosphere. Picture the oceans as a vast underground vault, holding these gases in check and preventing them from contributing to climate change. However, as the climate warms, there is a risk that these stored gases could be released, exacerbating the problem. Understanding the ocean's role in greenhouse gas storage is vital for developing strategies to mitigate the impacts of climate change. 10. Marine ecosystems and climate regulation. Marine ecosystems, such as phytoplankton, play a critical role in regulating the Earth's climate. Through photosynthesis, phytoplankton produce oxygen and sequester carbon, helping to maintain atmospheric CO2 levels. Imagine these tiny organisms as the lungs of the planet, breathing in carbon dioxide and breathing out oxygen. By understanding the complex interactions within marine ecosystems, we can better appreciate their importance in maintaining the Earth's climate balance. Protecting these ecosystems is essential for ensuring the continued health of our planet.